Hello. Oh, okay. Hello all, my name is Dilek and I am working at the Qt company. Today I am going to talk about the importance of textures on graphs, but firstly I will give an introduction about what I am doing at the Qt. Right now I am one of the person who are responsible to create a new generation for data visualization. This module is for visualizing and analyzing datasets by transforming them into visuals. And it can be used for visualizing depth maps or handling large amount of datasets. In our module, we have three types of graph. So you can either to choose create your datasets by transforming them into 3D scatter, 3D surface plots, or 3D bars. I will. Oh, okay, just a second. Okay. So one of the biggest difference between the old and the new generation was the old one uses a built-in rendering engine, which depends on an old version of OpenGL. But right now we are using Qt's own module, which is Qt Quick 3D. This Qt Quick 3D provides us a higher level of API to create 3D objects. So in this way, we don't have to create our specialized rendering engine for our module. So while transforming datasets into visuals, choosing the right color is very important for graphs because the color is basically essential to create visual appealing or informative visuals to users. We basically have two options, either to choose to color our object with color or gradient. And in our module, we are utilizing three types of color styles, which namely are uniform color style, range gradient, and lastly, object gradient. Right now, I'm going to explain them one by one. And also, I am going to show you an examples of how are we using them differently or on different graphs, actually. The first one is uniform color style. This color style colors object by using just one color. So it is very useful for basic visualizations and also small amount of data sets. Those 5 graphs are created with uniform color style. So in this way, we don't have to use gradient or either to color them with different color because we choose to use uniform color style. In this way, we are able to color them just using one color. So it enables us to create a faster graph. But if we have more color variation to represent our datasets, especially if a graph has multiple shapes or complex patterns or multi-layers, we will see in a bit. Range gradient provides much better results because range gradients color objects a portion of full gradient according to object heights and also their position of the y-axis. So for those types of graphs, it provides a very good result because it applies a smooth transition between two or more color, shade, or values. Other type of gradient-based color style is object gradient color style. This color style apply full amount of gradient regardless of any object parameter. So it is since it applies gradient independently of object heights or anything, it is a very ideal color style if a graph has more color variation, but it is not as complex as for examples that I gave for range gradient ones. So you may be wondering that where are we going to use that? And this is an example for it. These two types of graphs are created with object gradient. as you can see, points are densely clustered in an area. So let's think about either to use color or gradient for them. Using just one color to color them might be hard for us to distinguish one from another because it might not ensure color transition between points. On the other hand, using gradient provides much better results because it applies a smooth transition between colors, so we can able to see we can able to distinguish one point from another. And the question is how to choose between range gradient or object gradient if we are going to use a gradient for our graph. I would like to explain this with an example. This is a terrain graph which consists of 3 layers, and each layer has their own series, which means that each series have their own color style. I will get this in a bit, but this is an important feature for us because in this way we are able to create our series according to their purposes on a graph. So the first one created with object gradient, while the second one is creating with range gradient. Since object gradient created layers without considering their height or anything, this results that layers with close to them, especially if their heights are close, are being drawn incorrectly because it doesn't provide us a smooth transition since it doesn't looking at any of its parameters. On the other hand, range gradient provides better results, as you can see from the second one, because it looks at the object's heights. So we have smooth transition between layers and also within layers. I already mentioned that we have a feature in data visualization which enables each series can have their own color style. In this way, they can be created according to their purposes, like I said before. So those two are the examples for it. If you want to use more than one, we can say that if you want to use created one series with color or the other one is graded, you are able to do that with data visualization. So once the color is set, the other step is to choose a right material type for it. Materials basically describes how to mesh should be shaded for a model. So every model should have at least one material attached to it. In our rendering engine, currently Qt 3D has already have 4 materials, but we are using 2 of it, which are principal and custom material. We already learned that uniform color style is straightforward color style which involves minimum effort to use it. So to align with the simplicity, we are using principal material. The most important thing about it is a PBR metal roughness material. Maybe some of them already know the terms of it, but I will like to explain them. PBR, physically based rendering, stands for materials describes each properties in physically logical way, and in this way it gives us realistic results in every lighting condition. The other one, metal roughness workflow, is a very popular approach in computer graphics and 3D rendering subject. This workflow designed to simplify the process of implementing and also creating the material. And also we are able to create our models in a simple way. Since it is simple and effective, it is a suitable material type for our uniform color style. Principal material is great because of it is simplicity, but it doesn't provide programmability in the shader level. For those cases where our color style need different shading requirements, like gradient-based color style, we cannot use principal material. And the other important thing about why we don't use principal material with our gradient-based color style is that we have to create our gradient implementation in the CPU side, because we cannot customize our shader with principal material. And this decrease our modules performance, so we don't use principal material. Instead, we are using custom material with it because it provides us programmability on the graphics shader level by providing vertex and fragment shaders. And since we are able to implement our gradient implementation in the shader side, and since it takes on the GPU, it provides our module performance. So we are using custom material type with range gradient and object gradient color style. And this brings us to my end of my presentation. Today, I wanted to give an introduction about what I am doing at the Qt, what is data visualization, and what can be achieved with choosing the right color style and then choose a suitable material type with it. Thank you for all giving your attention and time to me. I hope you enjoyed my subject. Thank you.